Hello everyone, and welcome to the first video of this YouTube channel. The goal of this video is to explain the differences between two key concepts in physics, distance and displacement. So hopefully by the end of this video you will be able to distinguish between these two different variables in physics and how we actually can use them in different problems. We're going to see a few examples. So, to begin with the definition of distance, we define it as the total length of the actual path of an object and how this has moved. Okay. Variable, that's where it gets a bit fuzzy here, because depending on the textbook that you will see, depending on the curriculum that you're following, you might see different symbols being used. Okay, but for now, let's use D for this to show distance. Units on the SI unit, distance is measured in meters, and it is a scalar quantity, and this is key point number one. Distance is a scalar quantity, meaning that it has only magnitude, or in other words a size, or in simple words it just comes with a number, okay, and with no direction at all. So when we need to define distance, all we're interested in is just the absolute number of it. Now when we move into displacement, and let's see how it is different from distance, it shows you how much an object has been moved relatively to its initial position. Okay, that's the next key point here. We can also define it as the shortest distance between two points. What matters is only the final and the initial position. That's what we're interested in when we want to define the displacement of the object. The final position, where it ended its motion, and then relatively to the initial position, how much it has been displaced, how much it has been moved. Okay, variable, we use S for displacement. Okay, and soon when we'll talk about speed and velocity, we'll see a sort of confusion in that direction. Okay, but we'll see how we can get around this. Unit, again, it's meters in SI, but displacement is a vector quantity. Okay, and that's another key point from this video, meaning that displacement has a magnitude, a size or a number, so just like distance, but it also comes with a direction. Okay, and this will become clear from our first examples. So let's see the scenario I have designed here in example number one. Okay, so come with me to the football pitch where my team is training. Okay, and we have four cones, A, B, C, and D. Okay, and now our players will be moving the ball, okay, so here from A to B, from B to C, and so on and so forth. So the ball is being moved from A to B. The distance between all the cones is roughly 3 meters. Okay, so it's not a perfect drawing. So 3 meters from A to B, from B to C, C to D, and D to A. Okay, so now our players are moving the ball A to B. Then the player from B kicks it to the player who is waiting on cone number C, and then from C to D, and from D back to A. Okay, so the ball is actually moving like this and ends up in position A. Now, if we try to define the distance that the ball has traveled, in other words, the actual path that the ball has followed through this motion, okay, we basically need to describe the motion from A to B, from B to C, C to D, and then D back to A. In other words, distance between A and B is 3 meters, distance between B and C is another 3 meters, distance between C and D is another 3 meters, and D to A another 3 meters. In total, 12 meters. And that's the distance, okay? That's the distance, the actual path that the ball followed. Now, regarding displacement, as we said, we're only interested in the final and the initial position. what was the final position of this object? Position A, okay? So it was cone A. What was the initial position? Where did the ball start its journey from? Again, position A. So final and initial position happen to be the exact same spot, meaning that the object has not been displaced at all, okay? So the displacement happens to be 0. So you can see here a scenario where the distance is completely different than the displacement. Now, on the second example, okay, we have the ball moving from A to B, B to C, C to D, okay? And that's where the drill stops. Now let's see again in terms of distance and displacement what we have. Now again, the distance is A to B, okay, that's 3 meters, B to C, another 3 meters, C to D, another 3 meters. In total, 9 meters, okay? Now let's see displacement, where again, we're only interested in the final and the initial position. Now what's the final position? Where did the ball stop its journey? Its position number D, cone D, okay? The initial position is A. Now what's the distance between D and A? What's the final minus the initial position of the ball? D minus A, as you can see, it's going to be this distance over here, which happens to be 3 meters. So the ball has been displaced 3 meters to the right. You see, guys, this is another key here, okay? Because displacement, as we said on the definition slide, it comes with a direction, and that's what we mean by direction, okay? You say that the ball has been displaced 3 meters to the right. Look at that. From A, it followed this path, okay, from A to D. But how has it been displaced? It has been displaced 3 meters to the right, okay? Yep. Let's see example 3. Okay, in example 3, we basically have our players passing the ball simply from A to D, okay, cone A to cone D. What's the distance? A to D, simply 3 meters. What's the displacement? It's your final position minus the initial one, okay, so D minus A. So this one happens to be 3 meters to the right, okay. So in this scenario, you can see how both displacement and distance take the same value, okay? The advantage you're getting from displacement, since this is a vector quantity, is information regarding direction, because I can tell you that the distance is 3 meters, but I do not tell you anything about the direction that the object has been moved towards to, okay? But once you use displacement, which always come, remember, with the number, the magnitude as we call it, the size, and direction, you know the direction to which the displacement has been moved. I hope this has been quite helpful to try and clarify the differences between these two similar but not identical concepts in physics, distance and displacement, okay? One scalar and one vector quantity. In the next videos, we're gonna introduce time, and we can see how we can take it to the next step and talk about speed and velocity. I hope the video has been helpful. If you have any comments, if something is unclear, please write in the comment section, and then I'll get back to you. And since this is the first video of my YouTube channel, I would really appreciate your support, your feedback, any comments for improvement, and of course, like the video, subscribe to the channel. I hope I will be able to post on a regular basis some interesting content and create content for physics, and share with your friends if you think that you watched something helpful. Till next time.